Welcome, everyone. This is the November Temporal Meetup. I'm super happy to see all you here, some of you new faces, some of you regulars, and we're very happy to just keep growing this meetup. Our vision is that this is the first of many meetups. This is a company organized meetup, but as the world slowly reopens and people start to get together, we're happy to help you start your own meetups if you wish, or send people to your own company to do presentations for an internal meetup if that is also helpful. Okay, my name is Sean. I'm head of developer experience here at Temporal, and we have a packed schedule, so I'm just going to get right into it. So our main agenda for today, I'm going to give you some updates on Temporal. We're going to do a quick TypeScript SDK launch, and then we're going to go into our DataDog presentation from Jacob. Then we'll do two examples of the TypeScript SDK and usage, one from Jacob, from Baptiste, Devessier, and then another from FlightControl from Mina. So those be very exciting because FlightControl is our first TypeScript design partner that's actually a customer building their startup on top of Temporal. Okay, so some updates. We are going to be at reInvent. Rylan, Samar, Tim, and Smitty are going to be there. We don't have a booth or anything, but we're doing meetings. Just add us on Slack if you're at reInvent as well. Just want to make sure that anyone going to reInvent, we get to meet you in person and talk all the distributed systems. The next shout out I want to do is for Dominic. He's been doing a bunch of internal workshops as well as publishing some presentations that he's been doing called Inside the Temporal Loop. It's a deep dive into the temporal architecture and it brings you through step by step as to the lifecycle of what goes where and gets you to really understand the internals in temporal. So hit him up if you want anything of that sort. I sat in on one or two of those and it was pretty enlightening as well. Hey, Brandon, I see you in the chat. We're also doing monthly meetups now. We've committed to that. We are going to do a different language every month. So this month, obviously, because we just launched TypeScript, we're going to do TypeScript, and that's going to be next week. And these meetups are long form. Basically, we assume zero knowledge of temporal, and we're going to start from hello world and bring you through all the basic APIs that you need to know. And we'll stop along the way for questions. And it's 2 to 3 hours, and it's just we're just there to teach and guide you through every step of the way. So if you prefer that kind of learning, definitely sign up on temporal.io/workshop. Okay. Then the final update is Temporal V113. This was actually released last month, but it was after our meetup. So I just want to shout out those things. We have a bunch of fixes that are important, especially if you use enhanced visibility. And there's some smaller stuff like metrics, which I was really, really appreciative of because that's one of the more important things that people need for monitoring. And one of the other things that I want to shout out is also the SQLite driver, which we're going to actually touch on in our next talk.
Hello, and welcome to this introduction to Temporalite. My name is Jacob LeGrone, and I'm a software engineer here at DataDog. Now, this talk is about Temporalite, but before we get into that, I think it's helpful to have a better understanding of how we're leveraging Temporal at DataDog and what DataDog does. So DataDog is an observability platform that provides full visibility across your organization and allows everyone to have a shared understanding of your systems and the ability to immediately resolve problems when they arise. At DataDog, we care a lot about efficiently and safely releasing our software into production at scale, and over the last year, we've been investing in Temporal as a key component of our internal software delivery platform. So currently in production, we have Temporal workers for a variety of use cases, including data store operations, deployments, chatbots, pull request lifecycle automation, and source code changes, and so much more. So far, well over 100 individuals across tens of teams at DataDog have contributed to Temporal worker codebases. And here we can see a breakdown of our temporal activity executions by activity type and worker domain. Each unique color on this tree map represents a unique worker type, which is generally owned by one on-call rotation, and boxes are scaled relative to the total number of activity executions. So the top 10 workers account for about 99% of our activity throughput, but there are lots of lower volume use cases as well which don't show up on this map, which are nevertheless business critical. And here's a quick idea of our overall throughput. Right now, we're executing about 3 million workflows per month, and usage continues to grow rapidly. So as our usage has increased of Temporal, we've noticed some challenges developing against an operating Temporal day-to-day that played into our decision to invest in Temporalite. The first and most present for us today is that running workers locally during development can be extremely resource intensive. We run a temporal server and a single node Cassandra on developer laptops in separate containers via Docker Compose, and developers typically build and run their workers in Docker Compose as well. This whole setup takes a long time to get running at the beginning of each development session, and it can take nearly as long to update on each code change. We also end up spending a lot of time debugging problems as a team that are very specific to this environment, like bumping up default memory limits for the Docker VM. Another pain point is automated integration testing, or sometimes lack thereof. We have a staging temporal cluster that folks generally use for manually validating changes end-to-end before merging their pull requests. But that comes with all of the shared staging problems like non-production-like dependencies or broken dependencies, and occasionally racing with other engineers to find a window for testing a change to a common piece of code. And the last point here is that we do use Temporal to deploy Temporal. I can dig into this a little bit more later, but using Temporal as the foundation for our deployment system does introduce some interesting continuous bootstrapping challenges. All right, so before we dive into how Temporalite may help solve some of these challenges, and spoiler, they're not going to be solved by the end of this talk, I'd like to go over the temporal server architecture at a high level. So a temporal server consists of 4 independently scalable services. There's a front-end gateway for rate limiting, routing, and authorization. There's a history subsystem, which maintains data about running workflows. A matching subsystem, which hosts queues for dispatching tasks to workers, and a worker service that runs some internal background workflows. Now, these temporal services can run independently or be grouped together into a shared process, which allows you to run them on the same physical or virtual machine. And this is an option already present in Upstream. And then, of course, there's also a database component which provides storage for the system. We use Cassandra in our production clusters, but Temporal has a pluggable storage interface which allows it to support other data stores like Postgres and MySQL as well. Okay, so now that we have a high-level view of the temporal server architecture, let's talk about Temporalite. Temporalite is a distribution of Temporal that is shipped as a single binary and runs in one process with no runtime dependencies. It accomplishes this via a custom storage driver that leverages SQLite, and it also takes advantage of the fact that the other temporal server components could already be configured to run within a single process. Temporalite is packaged as a Go binary, but also as a library, which we'll talk about more in a moment. So aside from minimizing runtime dependencies, Temporalite's main features are that it supports storing all state in a single file. So you can easily fork your server state with a copy command, or email or Slack it to a teammate for help debugging. There is a in-memory mode, which is also supported pretty much for free as a result of using SQLite. And this makes it super easy to stand up and tear down temporary server instances. Startup time is nearly instantaneous from a human perspective, which makes it really well suited for local development use cases. And the project can be imported as a Go library, which provides facilities for writing end-to-end tests using the normal Go testing framework, or more advanced use cases like importing a temporal server as a Go library to make it possible to embed it as part of a larger application. And I did want to briefly touch on what the experience was like writing a custom storage driver for Temporal. Our original motivation for this project initially was really just to write a storage implementation and learn more about Temporal's data model and other internals. And we weren't necessarily expecting to have anything useful in the end. But my main takeaway was that it was actually fairly straightforward. Temporal's data model is really concise considering the problem domain. And the process mostly consisted of doing a copy paste of the MySQL driver code, plus an afternoon of chasing down errors and fixing up SQL statements in order to get a workflow to execute end to end. And we did eventually upstream the SQLite driver to Temporal Server, the Temporal Server repo a few weeks ago. And since then, we've been able to delete those 4,000 lines of code from Temporalite. And big shout out to the Temporal maintainers who were super helpful in reviewing and getting the SQLite driver code integrated into the Temporal test suite. So after we had something working and it proved out the usefulness of Temporalite for some of our internal use cases, we decided to open source it. And we did this primarily because we think it's useful and has a lot of applicability outside of Datadog. We also think it's a great way to drive further alignment and engagement with the upstream Temporal community. And we've seen a lot of this already with Temporal maintainers and other community members around the project. And we're really excited about this. And then a major technical reason to open source was that we wanted to move the SQLite driver out of the Temporalite codebase and into upstream. This is because the temporal storage interface is not necessarily completely stable, and moving this into the Temporal Server project allows us to deal with version upgrades much more easily because the driver code is now being tested with each code change to Temporal Server, and we can share some of that code review and maintenance burden with the upstream maintainers more easily, who are the experts after all. Okay, so what's next for Temporalite? We have a lot of ideas and plans. So the first thing is that we do have some work left to call the SQLite driver production ready. And we're working with maintainers upstream to improve tests around this and improve handling of some non-happy path scenarios in the driver codebase, especially around lock contention. We also want to eventually bundle the Temporal Web UI into the Temporalite binary. Upstream is working on version 2 of the Temporal UI and a backend gateway server, which is written in Go. And this should allow Temporalite to eventually offer more than just the headless experience it does today. And then internally at Datadog, we're working on integrating Temporalite more closely with our worker framework and local dev and CI processes. We'd like to make it as simple and fast to run workflows end-to-end in local dev and CI as possible. And we haven't forgotten that there is a unit testing framework for the Go SDK, but in the cases where we do want to write a true end-to-end test, Temporalite is our planned solution for that. And then temporal failover and federation testing scenarios are also important to us internally. As we work on building out our operational capabilities around failover and replication between temporal clusters, we plan to use Temporalite to be able to quickly stand up servers in a variety of topologies and test different failure modes. And then I kind of touched on this a little bit earlier, but having an option of embedding temporal in a larger application is really interesting, especially for deployments. So since we depend on temporal to deploy temporal, it's important that we have break glass options available for running potentially complex operations in order to recover from temporal outages. And we don't want to have to duplicate the business logic for these operational workflows that have already been implemented with the Temporal Go SDK in a completely different system, or do the work of hiding that we are using the Go SDK. So instead, we can use the Temporalite Go library to embed the temporal service alongside our worker code in a single binary, which can be run from a developer laptop or remote host. And then this is a little bit more aspirational, but we're also really interested in being able to run low dependency temporal servers in our edge environments. And we're looking at this project called Lightstream, which allows you to efficiently snapshot and persist SQLite state in blob storage like S3. So this would allow us to run kind of very small servers at the edge, which would still be able to recover from single node failures. All right, so that's enough talking. Let's do a quick demo. So I mentioned Temporalite is available as a Go binary or a Go library. First, we'll take a look at the Go binary. So we can go ahead and say Temporalite start, and I'm going to provide the ephemeral flag. So this is going to start up the server without any existing state, completely from scratch. And then in the second terminal window here, I'm just polling every 1/10 of a second for the status of the foo namespace. So you can see right now, I'm getting a connection refused error message, as you might expect, because I'm not yet running the temporal server. So I'll go ahead and start. And so now the error message has really quickly changed to the namespace foo does not exist. And this is because we are starting up without any existing state. So if I had previously registered the namespace foo in my last development session, it would no longer be there. So to deal with this, we provide an option from the CLI to pre-register namespaces. This works in ephemeral mode and in file persistence mode as well. So this is a little bit more convenient if you want to be able to right away start registering a worker and polling for work on a task queue within a namespace. So now we can see the namespace foo exists and we're ready to go. So the other interface to Temporalite is using it as a Go library. So if we take a look at the Go doc, we have the main package for Temporalite is provides facilities for importing a server type and constructing it. This is a little bit low level for most use cases, so we also provide a temporal test package, which allows you to really easily create a temporal server within a Go test suite and actually register your worker and run workflows end to end. So to take a look at what that looks like really quick, we can go over to this Hello World package, which defines a single workflow and an activity, and the workflow calls into the activity in order to return a response. So again, normally we would just write a unit test for this using the temporal test utilities that they provide. But if we want to write in a true end-to-end test with a real temporal server, we can pull in the temporal test package. And this is basically all the boilerplate that you need in order to instantiate a server, get a client, and register your workflows and activities. And then from there, we can actually write our test code that validates that we're getting back the response that we expected. And I'm just going to go ahead and break the test so we can see what it looks like when you don't get back the right result. So what's happening in the background is that we're standing up a full temporal server. When you use the temporal test package, then we'll automatically find open ports for you so that you don't need to worry about port collisions when you're running multiple temporal instances. And now we get back our results. So we can see the log line from our tests, that what we got was not what we expected. And what's also nice here is we don't show any of the temporal server logs, which can be fairly noisy. But we can see that we have access to the worker logs and to the temporal client logs that we used to actually start the workflow. So that is the demo. Let's head back to the presentation, and that's it. So thank you so much for listening. If this sounds interesting, please check out our previous talk entitled Software Delivery Building Blocks at DataDog to learn more about how DataDog leverages temporal as a key component of our internal software delivery platform. And please do reach out to me at LeGrone on the Temporal community Slack if this stuff sounds interesting and you'd like to work on temporal tooling and services full-time at DataDog. Thanks again.
That's me trying my new soundboard. Hopefully that was a little fun entertainment for you.
You can insert a laugh track next time too.
Hey, Jacob, there you are. Okay, I can't change square. All right, so we have some questions. I don't know if anyone wants to jump on the stream in chat. Actually, I don't have to share. Yeah, that was a really great presentation. Of course, a lot of people enjoyed it. I think Derek might have some questions for you. If you're live, I don't want to shoot you, but you were raving about this. Hey, Derek.
Yeah, that's just really awesome.
Introduce yourself.
Yeah, I'm Derek Wilson. I'm an infrastructure engineer at Temporal, and yeah, we're building tooling to deploy Temporal using Temporal and run into a lot of the same kinds of things that that you're solving with this, and we're really excited about it as well. So yeah, it looks awesome.
I think people want you to share that dashboard, essentially. Like Animesh also said, it'll be great if DataDog can also include the dashboard that Jacob showed in the beginning. It's an interesting visualization.
Yeah,
of like,
it was actually,
here's the activity. Yeah.
It's actually super simple to build that specific visualization. It's just a tree map using the existing temporal workflow completion and activity metrics. But yeah, I think we could probably talk more about that or like share some of our dashboards.
Yeah, I'd love to. I mean, obviously, you guys are the DataDog experts. All right, one more question, and then we'll go over to Baptiste. Two more questions. Callum says, "What's the con of using Temporalite over Docker Compose? Docker Compose is pretty simple, one command." Yeah, I think it's like speed. And what's the con of using Temporalite? Basically, what are the downsides?
No Elastic.
No Elasticsearch. No web UI. You're not exactly replicating bugs that may be happening with Postgres or MySQL or whatever, but that should be abstracted away for you from Temporal. I'm not sure.
So one of the reasons that we want something like that. Sorry, Ryland. The issue of running Docker containers inside of Docker can be fun, right? Like a lot of build pipelines use Docker to execute your tests and things like that. So not needing to run Docker Compose inside of a pipeline that you want to run on Docker containers it makes that easier.
Yeah, I think also I was just going to say that I'm not necessarily sure it's fair to say that not having temporal web is a downside, because you can, as far as I understand, still use temporal web. It just doesn't come out of the box with Temporalite.
Yeah, you have to hook it up.
And like I said, we're really excited about the V2 of the web UI, and I think eventually should be able to integrate that into Temporalite as well.
Yeah, very cool. If there was one thing that you think like external contributors might be able to stick their teeth into, what would it be?
As far as changes we'd like to make to Temporalite?
Yeah.
I think like I said, the SQLite driver is not production ready yet. So that does now live in the upstream Temporal.io/temporal repository, but I think most of the work remaining is to get that ready for production and just find all the edge cases and bugs that exist in it right now, I'm sure.
Right, exactly. So basically, people need to use it and find bugs. But obviously, you've been using it in your daily usage already at DataDog, and we're really appreciative. All right, final plug for the jobs. You said to ping you if you want to work on if you want to work full time on Temporal at DataDog. I don't actually know which JD it is, but like I took a look around, and is this it? Because this seems to be the team that reflects your team. I'm not sure.
Yes, just ping me before you apply.
Okay.
We have job openings across multiple teams that don't specifically mention Temporal, but they are definitely available, and I can help you figure out what the best fit would be.
Awesome. And if anyone wants to know more about the talk that he referenced, Jacob's talk, I've actually put a short link, temporal.io/datadog, and that's going to link straight to how they use Temporal as well as the other software delivery building blocks that they have at DataDog. I thought it was a really great presentation. I forgot one more thing which I need to do, Baptiste, which is that I need to introduce the TypeScript SDK a little bit, because we just launched it, but we didn't really talk about it or introduce it to people. And the next two speakers are related to the TypeScript SDK. So I wanted to give some context. So let's just go an overview for people. This is more for people who kind of know what Temporal is, but may not have ever looked at the TypeScript SDK at all. So this is kind of the workflow API that we've landed on, both from defining the workflow as well as calling it. And you're just kind of calling it with workflow.start, workflow.execute, whatever that is. And a workflow is a simple function. An activity is also a simple function, but this runs in Node.js, and you have all those Node.js capabilities there. And you can call it inside of a workflow by a special process that we call proxy activities. Proxy activities is how you sort of import a workflow, an activity into a workflow, but you also are able to set all the retries and timeouts that Temporal is well known for. And obviously you can also adjust them, for example, like no retries by setting maximum attempts of 1, maximum 5 attempts, but with no exponential backoff. This is very configurable and declarative, and is a great way to separate the concerns of calling activities versus orchestrating them. Okay, and then the last two APIs are the worker, where you, for example, like you start a worker and then you register the workflows and activities, and that's a very simple API right there. And then finally, we have the workflow APIs, which are, for example, timer, where you have like workflow.sleep, and we accept strings instead of just numbers of milliseconds, and that's supposed to be a very nice developer experience move. And then also you can do you can build the standard abstractions on top of those. Signals, you can define signals and queries, and then you can also set handler on them. I forgot to change the slide, but you can also set them inside of a simple workflow object. So workflow function. So yeah, it's a pretty simple API. I wanted to give that broad introduction before we go into Baptiste's presentation. Okay, let's go into Baptiste, if you're ready to talk about temporal and XState.
Yes. Do you hear me correctly?
Yeah, you're good.
Perfect. So my name is Baptiste Devessier. I am a student at 42 Paris School, and today I'm going to show you how we can use XState to create declarative workflows with Temporal TypeScript SDK. So I built a GMO electronic signature application using XState and Temporal. You select a file, and then you confirm it. Yes, you confirm that you want to sign this document. Then you fill your email address. You will receive a confirmation code by email. So check your emails. And when you receive the email, you can grab the confirmation code from it. You paste it in the application, and it will validate the procedure. Your document will be signed, and you will be able to view it. So the first thing to understand is what is a state machine. A state machine is an abstract machine. It has a finite number of states and can be in exactly one state at a time. It has an initial state and is waiting for inputs, also called events, to trigger transitions, that is, going from one state to another one. Transitions are deterministic, and it's quite important in the context of temporal workflows. XState is a library to create state machines in JavaScript and in TypeScript. It can be used in any JavaScript environment, such as a browser, Node.js, and even temporal workflows. Let's take a look at fetch machine example. So this is a fetch machine that you can use to fetch any data from anywhere. The initial state of the machine is idle state. In idle state, you can receive a fetch event. It will trigger a transition to loading state. In loading state, the fetching happens, and two things can happen too. Either the fetching resolves, and you go to success state. Otherwise, if the fetching fails, you go to failure state, but you can still retry and go back to loading state. And this time, it can succeed. So now that we understand what are state machines, let's apply them to temporal. I am in the workflows file. Here, we can find the definition of electronic signature workflow. All the logic of the workflow is driven by a state machine, this state machine. So The initial state of the machine is pending signature. Pending signature is a state that has substates, and the first of them is waiting agreement. In waiting agreement state, we are waiting for an XState document event. And when we receive this event, we target waiting email state. In waiting email state, we are waiting for the user to send us her email. When we get it through a set email event, we go to generating confirmation code state. In this state, we invoke a service. A service is where we can interact with activities and also spawn child workflows. So if we go to generate confirmation code service, we can see that it uses the activity of the same name. This activity is defined as follows. It uses NanoID to compute the confirmation code. If we go back to the state machine, we can see that once the generation is done, we target the next state, sending confirmation code. By default, a state machine is a declaration. It does nothing. To make it real, we have to interpret it. So inside the workflow function, we use interpret function from XState. It takes the state machine and returns a service. A service is the engine that powers the state machine. We configure the service. We say that for each transition, we keep track of the updated state inside state variable. And then we start the service. Signals are defined using Temporal API, define signal. Let's take a look at accept document signal handler. It's defined here. All signals handlers do is sending an event to the state machine. All the logic is inside the state machine. For queries, we have to use the current state of the application and compute some data from it. One really cool thing with XState is that we can create timers declaratively. Here, we can find a timer creation. So when we enter in pending signature timer, we will create a timer of 2 minutes. If after 2 minutes, the procedure is still pending, we'll target to procedure expired state. It means that if we exit pending signature state before the timer ends, the timer will be canceled. By default, XState uses set timeout and clear timeout to manage timers. But with Temporal, we have to use sleep function. This is not a problem. If we go back to the workflow definition and to the call of interpret, we can see that we provide a custom clock implementation. We override set timeout and clear timeout functions. In set timeout, we call sleep, but we have to wrap the call inside the concession scope so that we return the scope from set timeout and clear timeout function will get it. And when we want to clear the timeout, we cancel the scope, and as a consequence, it will clear the timeout. Another thing we have to do, so inside the state machine, we have 3 final states. A final state is a state in which we can no longer receive events. The state machine is done. We want the workflow to wait for the state machine to reach one of these 3 final states. So the final states are expired, validated, and canceled. We can use inside the workflow service.onbound function. It takes a callback and will call it when the state machine reaches the final state. So we await a new promise we build, and the workflow will be kept alive until the service, so the state machine, is done. At the end of the workflow, we can compute some data from the final state of the application and return it. This is how we can use XState to create declarative workflows with Temporal. So thanks to XState, we can make the behaviors of Temporal workflows explicit. Everything that happens inside the workflow has to be modeled in the state machine. And state machines can even be visualized. If we go back to the definition of the state machine, so here we can find an Open Inspector button on top of it. It comes from XState extension for VS Code. If we click on it, we can see that the state machine is loaded we recognize pending signature and waiting agreement states, and we can interact with events. So even non-developers can understand the workflow thanks to this feature. State machines prevent impossible states and race conditions because you have to think them ahead. They are part of your model. And finally, state machines scale well. You can add features and therefore states and events without your lines of code increasing dramatically. But to make use of XState with Temporal, you have to understand what are state machines and state charts. State charts are an evolution of state machines. And you have to understand how you can use those principles inside a Temporal workflow. Currently, there is some boilerplate to write. You have to write a custom clock implementation and map manually signals to events. In the future, it will probably be solved by the community. Thank you for watching. You can find me on GitHub, on my personal website, and on Twitter. The code of the demo application is online, and my slides are too. Thank you.
Thanks, Baptiste. That was amazing. I actually started the applause track. I forgot to unmute myself, as that always happens. Baptiste, actually, we have a, and also I didn't expect a guest appearance from David Khorshid, who actually created XState. So he's available in the chat as well if anyone wants to ask you questions. Baptiste, are you still around? Did you peace out? Oh no.
No, I'm still here.
Oh, okay. I saw. Awesome. I think we had a couple questions that we might want to that we have a lot of questions actually. Let's have Prastoin. Are you able to ask a question live, Prastoin?
Yes, of course.
All right. Yep. Fire away.
So I was asking, why haven't you used the XState model in your demo? Are there any regression by using it with Temporal?
Yes, you are talking about create model from XState?
Yes, of course. The TypeScript one.
This is a feature that has been brought in newest versions of XState. It can be used totally in the Temporal workflows, yes.
Right, cool.
Okay, thanks.
Yeah, exactly. And then I think Roy actually had some commentary on the set timeout and clear timeout that we probably should have double checked in your demo.
Okay.
But we actually mock those out inside of the workflow environment. It's part of the service that we do. Roy,
yes.
Any other comments that you wanted to provide?
Yes. One great thing about using sleep instead of set timeout and clear timeout is that thanks to sleep, you can cancel the timer. Even you can create concession scopes and hierarchical concession scope, which you can do with a clear timeout implementation.
Right, exactly. So the way we phrase it is sleep is cancellation aware. Sorry, Roy, you were going to say something.
Yes.
Roy? Oh, no.
Yeah, that's what I wanted to say. So yeah, I thought you were using XState for like handling cancellation and stuff like that. So if you do that, then you don't need temporal cancellation scope integration.
Yes.
Ooh. Oh, okay. Yeah. So depends on whether state machine inside or state machine outside. Yes, and I think to address one of the things, the downsides that you mentioned about the XState boilerplate, I think David has some really cool ideas for reducing that. So even though like the state charts spec is a very well tested spec, but yeah, it's a common pain point. I think there's a lot of plans in place. Hopefully, Stately or XState will show the way in terms of how to do this right.
Great.
Awesome. Thank you so much, Baptiste. Round of applause again for everyone. And thank you so much. That was a great presentation. Check out the GitHub demo.
Thank you.
Okay. You see, I need an audio engineer because I'm not well presented on this. Okay, so that was Temporal plus XState. We're going to have that talk available here on this URL eventually. So check that out, temporal.io/XState. And hopefully we'll have David come on and present something in future. I think I already saw in the comments that people wanted some kind of Python integration, which would be interesting for both our companies. the final one that we have is flight control, which I'm also very keen on. Mina is a friend now and has been working with us as a design partner. So Mina, are you ready to present?
All right. Thanks, everyone. Thanks, Sean, and thanks to Temporal team for having me. This is Mina Abadir. I am the co-founder of Flight Control alongside Brandon here. He's also a guest with us today. We both are building Flight Control, which is a full-stack deploy platform that runs on your own cloud. So imagine Heroku-like experience running on your own AWS account, basically, with the same great developer experience that we love. We are also a design partner, as Sean has mentioned, for the TS SDK. Also, Flight Control is built by the same team behind Pleds. So Brandon started Pleds.js over a year ago now, approaching 2 years, which is also a full stack React framework. And I think the success story that recently we were celebrating 10,000 GitHub stars in less than 2 years. I think that was a great record. So congratulations to Brandon and the whole Flight Control team. So we're here today to talk about our story with Temporal and our journey. So I remember when we started using the Temporal SDK over 2 months ago. Kudos to Sean, Rowie, and the team building the SDK. It wasn't as polished as it is till now. Like I have seen huge changes to the API. So amazing job. When we started to use Temporal, we had two main services in mind. We have the dashboard or the web UI that we need to build, and we have the asynchronous build pipelines that we need to build. So for the dashboard, that was easy. We are creator for Pleds.js, so we're going to use Pleds.js. However, for the asynchronous pipelines, we needed a different tier and actually Beast to manage this. So here are the problems that we needed to solve. So we wanted something that's fail-safe and reliable. This will be the core of our business, something that's scalable, and we have granular control over the workflow as it runs. And once we figure out all these stuff, that's good. Now we have to build our business logic, because none of that is the core of our business logic. This will not do the deployment. This will make sure that our deployments are reliable and scalable. So we have actually looked into alternatives. So one of the big alternatives is any queuing machine, SQS, RabbitMQ. However, the problem with those when we started them is basically they don't scale well. You have to do all the failure management on your own. You have to prioritize the jobs in some way. Once the job started, you're completely blind. Like it's very, very difficult to see which node or which compute unit is actually processing your job. So it was very difficult for us. It wasn't going to meet any of our requirements. This is when we started to work with Sean and the team to bring Temporal. So this is how we are using Temporal in Flight Control. Basically, whenever one of our users or developers is starting a new project, we are starting a new infinite workflow. So we are heavy on infinite workflows, basically a workflow that starts and it never ends. It only ends whenever the user deletes the project or whenever the project is no longer required. So we were initially considering Temporal to run for us as asynchronous processing, job processing. However, we thought let's benefit from the scalability, let's benefit from failure management and state management. For us, which is in line with the XState presentation, we think of Temporal as a state management framework, basically, for the backend. So for example, projects are infinite workflows, environments, like whenever we are starting a new project, there will be different environments like staging and production. those are also like child infinite workflows. Deployments or activities that runs within the environment's workflows. AWS resources are being provisioned through small short-lived workflows. So those are not infinite. That's how we're using basically the workflow. Here's the code. You can see that we're doing some state management through awaiting for signals whenever we are waiting. For example, the user started a project. We wait for some time till the user provides us with their AWS credentials. Once the AWS credentials is provided, we continue processing, storing the AWS credentials and start to provision the environments. So somehow state machine manually. So probably we'll look into using XState now. Also, we are using signals heavily. So whenever the user is making a good like push to deploy or like get push or something, we need to pick this up and send the signal into our workflow because they are infinite workflows. So we need a way to send instructions into the workflow. This is where signals will come into play. So whenever there is a get push or whenever we need to send instructions to the workflow, we use a signal. And the nice thing about signals, they are running asynchronously. So even the same signal can be triggered multiple times at the same time, and Temporal will handle them all. So that's how we're doing it. For example, if there's a get push, we get the branch, the commit, the information that we receiving from GitHub or any Git service, and we push them into pending deployments, and the workflow afterwards will handle those deployments. So we check when we're having like a condition, once the pending deployments are more than 0, we start to push the deployments to the environments. Also, we are even using some of temporal features to power or empower our business logic. For example, because Temporal has a first-class error handling, we are actually using the error handling to empower a nice business logic when we are issuing an SSL certificate for a domain. We want to make sure that the SSL certificate is validated. We all know whenever you are validating your domain ownership, you have to go to your DNS, you have to add a CNAME, you have to do few things, and in the meanwhile, we need to check or keep checking that whether AWS has provisioned the certificate for you or not, because it's happening completely offline outside AWS and outside our application. The user is actually adding a CNAME, for example, on their register. So how we're doing that is, for example, we here define or add a proxy to an activity, and we are doing retries, for example, 400 times. And we are doing exponential retries, so we don't hit AWS many times without a real need for that. And what we're doing here is we keep retrying. Once we hit the 400 retries, we start a new workflow. And once the SSL is provisioned or like issued by AWS, what we do is we take this and update our records, update our systems to make sure that we can now use this SSL because now it's issued, and we end the workflow. So even using some of the features that we think can just for error handling, no, we can actually use it to empower business logic as well behind that. And that's it. So that was it for me today. If anyone has any questions, you can find me here, Abadir _ on Twitter, and you will find our Twitter and web URL for flight control. Also, you're brave enough to listen to our podcast. Brandon and I are producing a weekly podcast called Flight Review. You can also find links to Pledge.js on Twitter and web.
Awesome. That is another applause round. There we go.
Thank you.
Trying to do the sound engineering on my side as well. I wanted to plug that podcast again. We've actually been listening to it here at Temporal as well, and it's pretty scary to have your users podcast about you and then and not knowing what you're going to say. But it's a fantastic podcast. Flightreview.fm. Does anyone have questions for Mina? If you're thinking about putting Temporal or Temporal TypeScript into production, he's a very good resource. Brandon, his co-founder, is also here. Anyone questions about just general stuff like that?
Yeah, Sean, just the one thing is, do we have another presentation if we do the
Nope.
time is? Oh, okay.
Yeah, this is it. I timed it for 55 minutes, and then we always have a bit of buffer in case anything.
Hey, your timing skills are obviously flawless.
No, well, I fumbled some stuff along the way, but nobody knows. All right. If nobody has questions, Mina, that was fantastic. I know you worked really hard on this, and I know that it's a crunch time for you as well because you're going to production with your design partners, and it's funny to have a design partner of a design partner, but we're committed to your success. If anyone else wants to sign up for some kind of design partnership with us, work with us closely on the TypeScript SDK. Now that we're in beta, our APIs are very stable. But we're looking to go into GA early next year. Okay. We have a first question from Sergey. Maybe we need that flight control pitch. Does either of you, Brandon or Mina, want to do the flight control pitch?
Yeah, sure. So flight control is a SaaS service basically, very similar to like Heroku, but we take your code and deploy it to your AWS. And if you're interested, you can go to flightcontrol.dev. You can join the waitlist or join the insider, the pre-launch insider program, and you can be one among the first to join us. So we are planning to onboard the first few customers this month. So before the end of this month, this code should be on production. So we're crossing our fingers here.
Thanks for that. Okay, I think we have one last question from Rupali, who's been working with Convoy. Rupali, you want to ask your question? You can come on screen and then we can just talk. Let's see if I can make this happen.
Hey.
There we go. There you are.
Hey.
Yes.
So you guys just released the beta today, which is very exciting. I'm curious, you said that you're planning GA early next year. What's going to be on like your list of things to do to decide like, okay, we're ready for GA, and like what is the difference maybe in stability of APIs that we can expect at that point as well?
APIs are quite stable now. We're just not ready to say that they will never change. Roy can also back me up on some of the discussions that we've been having, even going to today. So what we can say is there are some features that we really want to get to. Testing, data converter, sessions, side effects, local activities. There's a bunch of sort of smaller features that are very important for advanced users that we really want to get to. Search attributes. I don't know if you've actually checked those things out, Rupali. They're pretty cool. Roy, did I miss anything?
Yeah, there was the async activity completion. That's
async
missing too.
Can you explain what that is for people who may not know?
It's basically if your worker picks up an activity, instead of completing in that same worker process, you can basically just save that activity for later and use the activity ID or either the test token or activity ID. You can just save information to complete this activity later. So you can use it for like manual completion, but not necessarily the recommended way to do it. So I've found out lately.
Yeah, it's one of those like things you don't really think about until it starts to become relevant.
Yeah, you can just complete the activity from a different process. It's basically just letting the worker know that I'm not going to complete this activity now, forget about it, and you just basically take the activity into your own hands, right?
Right. Yeah, exactly. Rupali, hopefully that answers your question. And obviously you're in chat every day with us. and we're happy to. I mean, I hope the experience has been okay. I know you had some trouble connecting to a cloud. Yeah, you're right. All right, cool. I'm gonna call it there. It's on the hour exactly. Thank you so much for joining. Go upvote us on Hacker News if you feel so generous. Otherwise, we'll see you next month. For those who are still interested in the workshop, we'll be doing the full workshop next week, and me and Tio will be leading that one. All right, thank you. Have a great day. I'll stick around for like any like off-camera questions. I'm gonna stop recording.